Hello there, welcome to the A-Level Maths Pure Paper 1, June 2023. Here we're looking at question 9. The first three terms of a geometric sequence are 3k plus 4, 12 minus 3k, and k plus 16, where k is a constant. Part A is show that k satisfies this equation here. Okay, so if it's a geometric sequence, then we know that the multiplier to get from this term to this term is the same, and to get from this term to this term is the same. Now, to get the multiplier between the first two terms, you would divide the bigger term, or not the bigger term actually necessarily, but the second term by the first term. And given that the multiple is always the same, this is going to be equal to the third term divided by the second term. We can set these two things equal to each other because the multiplier from one term to the next is always the same in a geometric sequence. So what we're now going to do is do some cross multiplying. So the 12 minus 3k from the bottom right now moves to the top left. And the 3k plus 4 now moves to the top right. Cross multiplying, that moves to there, that moves to there. Expand your brackets, 9k squared minus 36 minus 72k, add 144. Equals 3k squared, and I'm going to do this on my calculator, 16 times 3, add 4, 52, k, add 16 times 4 is 64. Right, so we're now going to move everything onto the left-hand side, so it gives us 6k squared minus 72 minus 52, gives us 124. And 144 minus 64 gives me 80. Looking at the answer, if we divide by 2 now, we're going to get 3k squared minus 62k plus 40 equals 0. Excellent. There we are. So that's part A sorted. Right, now, given that the sequence converges, find the value of k giving a reason for your answer. So now we're going to use the quadratic formula. So 62, or we can use the quadratic formula if we wanted to, minus 4 times 3 times 40 over 6. Okay, so the different values of k are, k is 20, and if we were to use the minus symbol, that would give us 2/3. Okay, now we need to decide which of those two is going to satisfy the result that this is a sequence that converges. For a sequence that converges, we need the modulus of r to be less than 1, i.e. the ratio to be less than 1. How do we work out the ratio? Well, it's either of these terms on the left or the right hand side. So 12 minus 3k over 3k plus 4. I'm first going to substitute in when k is 20. So fraction button, 12 minus 3 times 20 divided by 3 times 20 add 4 gives us minus 3 over 4. So that is a potential value that we could use for a converging sequence. And when k is 2/3, let's go back and substitute in 2/3. Bear with me, I'm just doing this all on my calculator at the moment. We get 5/3. 12 minus 3k over 3k plus 4 gives us 5/3. So it's definitely not this one here, because that gives us a common ratio above 1. It's definitely this one here when k is 20, because that gives us a common ratio that's less than, the modulus of it is less than 1, between minus 1 and 1, which is minus 3/4. So it's definitely k is 20. Find the value of s infinity. Okay, so what we need to work out s infinity, the formula for s infinity is a over 1 minus r. So we need to work out a, and we already know that r is minus 3/4. So to work out a, we're going to substitute 20 into 3k plus 4. So 3 lots of 20 add 4 gives 64. So now S infinity is going to equal 64 over 1 minus 3/4, so 1 plus 3/4. 64 divided by brackets 1 plus 0.75 gives us 256 over 7. 256 over 7. And there we are. That's the right answer. So there we are. That's the answer to question 9 with a total of 7 marks. Let's now move on to question 10.